Okay, we're going to talk a little bit about interpreting trapezoids. Now, if we have a graph of pay rate versus clock time, pay rate in dollars per year versus clock time in years. And if the pay rate is $40,000 at this clock time and $55,000 at this clock time, where 10 represents the width of the trapezoid, and when we have the axes completely drawn out like this, let's just say that we understand that 10 is this width. Later on we will be labeling this axis with actual clock times. In other words, the years might be 2007 through 2017 or 1998 through 2008, a 10-year span. And we would want to also be able to label these on the graph. At this point, we define a trapezoid only by its width, so the 2 years are not part of this labeling at this point. Okay, well, this means that the pay went up from $40,000 to $55,000 a year in 10 years. Now, we could ask two questions about this. The two questions we naturally ask in this point are, or at this point, are what are the slope and what's the area? So we're going to have a box up here in which we want to indicate the slope. Okay, make it a pretty wide box because they're going to be units. And here where we can indicate the area. Okay, that's the labeling. Let's actually calculate the slope and the area. Okay, the slope of the approximating segment is what? Rise is, well, it really helps. It's a really good idea when you're first getting used to this to actually draw the run and the rise so that we can see that the rise is from here to here. So the rise is very clearly 15,000. Well, actually it's $15,000 per year, but we're not going to include the units at this point. We'll include them down here. And actually, take that back. I am going to include the units here. Okay, I've included the units. This is a little inconsistent because I didn't include the units here and here, having indicated that the pay rate is in dollars per year. But just to remind ourselves of what this means, that's $15,000 per year. So, well, when I calculate the rise, I am going to include the units. So that's 50,000. And I'm going to write it out, dollars per year minus 40,000, and that's 55,000. I'll have to correct that. But $50,000 per year and $55,000 per year minus $40,000 per year. Let me make that correction. Okay, 55,000 minus, and I've gone ahead and done the subtraction. We get $15,000 per year. And I've written out dollars over years rather than $sign here and years here, just so we can deal with the units a little more rigorously. Okay, so we have the rise and the run, so the slope is going to equal rise divided by run. That's 15,000 dollars per year divided by 10 years, which is 1,500 dollars per year Okay, we have dollars per year here divided by years here. This means that your pay goes up $15,000 per year, on the average, remember this is the approximating segment, we would generally expect the pay rate to go up more in a curved fashion. The more you make, the more your pay goes up, although that's not always the case. We don't know anything about how the pay changes from here to here, but on the average, it's going up $1,500 per year. You get an extra $1,500 per year every year. Okay. Now I've abbreviated that somewhat and had to make my box a little larger. I knew I hadn't made it large enough. $1,500 per year. Now, if I want to express this more compactly, I can make that dollars per year squared for the same reasons it worked out that way in previous examples, analogously. In other words, meters per second divided by seconds was meters per second squared. But rather than dollars per year squared, I've chosen this at this point to make sense of it. It's the number of dollars per year change per year. Now we want to calculate the area of this trapezoid. Okay, we want to find now the area of the graph trapezoid, and that's going to be, as we've seen before, the average of the two altitudes, graph altitudes, multiplied by the width. The average of the two graph altitudes being the altitude of the equivalent rectangle. So that's going to be $40,000 per year. The average graph altitude is $40,000 per year plus $55,000 per year divided by 2, the average of the two, which is $47,500 per year. And the width is 10 years, so the area is product of the average altitude times the width, which is $47,500 per year multiplied by 10 years, which equals $475,000. Since dollars over years multiplied by years, I don't like crossing out the years. People do it wrong all the time. It's dollars times years over years, which is dollars times years divided by years. Years divided by years is unity. Multiply that by dollars, you get dollars. Okay, so the area represents $475,000. The slope represents $1,500 per year. So what's our interpretation of the slope? Well, $1,500 per year is the change in salary per year. Okay, I'll call this salary because we're talking about a rate of change, so we can talk about the average rate at which salary changes with respect to clock time. Clock time here, pay rate or salary up here. And of course we can also read salary as pay rate, which is what we originally said, and then we have the average rate at which a pay rate changes with respect to time. So we have the rate of change of a rate. Okay, so that's a little more confusing, but that's actually what's going on, and we'll deal with that sort of thing later on, or progressively as we look at a couple of other examples. Okay, just made a couple of slight changes. The word rate wasn't very clear there, and I should have said clock time instead of just time here. Now, the question is, what does the area mean? That's a fairly straightforward interpretation. You should think about that. Well, intuitively, the meaning of this is pretty clear. If we have an average pay rate of $47,500 per year, then in 10 years we're going to make 10 times $47,500, or $475,000. Now, this is a more formal calculation, and we want to do the more formal calculation to make sure it agrees with what we expect, what we think is going to happen, what our intuition tells us, what our deeper understanding of the meaning of this thing tells us, but that's the meaning. So we can complete labeling the graph. Didn't make my circle quite big enough, but I've got 475,000 D for dollars. So that on this graph, the slope represents the average rate at which our salary or pay rate changes with respect to clock time. And this is the amount of money that we would make if our approximating line is accurate. Again, we don't know for sure what might have happened to the salary between here and here. In 10 years, a lot could happen. Could have gotten demoted and then promoted and then demoted again. So this thing might not be, the actual graph might not be a straight line, but given just this point and this point, this is our best estimate of what we might expect to happen. At least this is our linear estimate of what we might expect to have happened during that time.